For Unit 11, Lesson 3, Two-Way Frequency Tables. The goal of the section is going to be calculating probability using two-way frequency tables, which you may remember back from Math 1. So remember, a two-way frequency table is a way that we display two categories using the same sample. So we're going to see in this first example, we're going to be comparing different categories, so cat versus dog, and apartment versus house. If you remember, we also have like subtotals and then a final total, which will be the sample size. In this case, it'd be 1,547. So let's start calculating these probabilities out. So the first thing we always want to look at is how many people are represented in this data. In this case, it's 1,547. We have these different categories that are breaking up this data into cat versus dog and apartment versus house. So the first one is asking for what's the probability that someone owns a cat. So remember, it's the total of favorable outcomes over total possible. So in this case, it's for the entire table. So my denominator is going to be 1547. And of these people, of 1,547, how many own a cat? And it's going to be 799 people own a cat. So my probability, if I divide that out, would be 0.516. For a dog, same thing. I'm going to have my denominator be 1547. And the total that owns a dog is 748. And if we divide that out, we would get a 0.484. For the next one, this is actually going to be a conditional probability. So our denominator isn't going to be our entire sample. It's out of the people who live in a house. So of the people who live in a house, that would be 910, which will be our denominator. And of these 910, how many have a dog? That would be 586. So if I divide that out, I would get 0.644. For the next one, this is the union. So we're going to take this out of our entire amount. So what's the probability that someone has a house or a dog? So for this one, if we look at our values, we're going to use our sample size as our denominator. And what we're going to end up doing then is I'm looking at people if they have a house. So I'm also looking at if they have a dog. But I don't want to count anybody twice, right? So I can't count the house and dog people. So I can't just like simply add these up because I would have been double counting that 586. So you can either add them and subtract, or some students just find it's easier just to add those like different these different frequencies within the chart. So if I add up 324, 162, and 586, those three values, that's going to end up giving me my numerator, which is 1072. And then when I divide it, I'd get 0.693. And then finally, for my last one, what is the probability that someone it has a cat and an apartment? So again, I'm taking it out of my sample size, which is 1,547. And a cat and an apartment is going to be 475. And so my probability would be 0.307. For the next example, it's the same concept. We just have to fill in our different frequencies. So we have these joint frequencies that we're filling in now. And we know what our totals are, or part of our totals. So I know I have this total for the row and for the column. I don't know how many are in the entire sample yet, but we can kind of just fill in the blanks. So I know that 50 plus some value for adults who chose fiction is 85. So if I do that subtraction, we're going to get this to be 35. If I add this across, I'm going to get 45. If I add it down, I'll get 105. And then I can just do the subtraction to get those other pieces. So really, it's just kind of like you're adding and subtracting to get those joint frequencies in there. Now we can go ahead and calculate all of our probabilities like we did before. So probability that there's a child, that the person you chose is a child. So our sample size for this is 105. So that's going to end up, so 105, so that's going to end up being our denominator. And of that, how many are children? So there's 60 children. So 60 over 105 is going to end up giving us 0.571. And then the next one is probability that they're chose nonfiction given that they're an adult. So of our adults, 45 would be our denominator. And then 10 chose nonfiction, so 10 over 45, which is 0.222. The next one is not conditional. It's the probability that they're a child or chose fiction, so either or. So it's going to be out of 105. And if we look at our frequencies with that, so children, there's 50 and 10. And then fiction, 35 and 50. So if we add all those up, we'll get that to be 95. So that would be 0.905. For the probability of fiction and an adult, so the denominator is 105. And for fiction and an adult, and then that would when it was a 35. And so we would get that to be 0.333. And then finally, the probability that someone is not an adult. So if I look at how many adults we have is 45. So not an adult would basically be a child. So that'd be 60 over 105, which is 0.571. If you have any questions, please make sure you ask them during T-Bowl time, during class, or you can come to the center. And remember, you do need to complete the You Try problems to receive full points for the notes.